When we set out to actually design SMaRC and do the whole project as SMaRC, where can we actually, with these technologies, make a big difference? We identified then these 3 global impact or benefit areas. And in all of these 3 areas, we think that using underwater robots can have this big system change or disruptive change in how we can access the environments and also cover areas with less risk to humans and less cost. What we're really seeing here is how we are connecting with all our stakeholders in SMaRC. We're really trying to connect the different pieces of SMaRC together so that we can share information and share knowledge and understand what really big challenges are. It's really have a shared knowledge base is kind of, I would say, the essence of what we would like to create here. So the 3 benefit areas that we have are 1, ocean production, and then 2, environmental sensing, and 3, safeguarding society. The first one is ocean production, which is about how we can use the resources of our oceans in a sustainable way.
What's going on here at Kristineberg is that we are cultivating algae in so-called sea farms.
Basically what we're doing is we're developing robots that have the technological capabilities to apply to these different areas in a more efficient and safe way.
If you have these new forms of underwater robots, we can really change the way we look at our planet. They can give us access to areas we previously could not access. They can allow us to do things we previously could not think of doing.
In the algae farm scenario that we're looking at here in Kristineberg, the robot is supposed to go to the farm, survey the walls to make sure that everything is all right, and then come back, and then you have your data.
We want to do this because we are living in a fossil-based society, and we want to turn this society into a more sustainable society that is a bio-based society. And in order to do that, we need a lot of biomass. And we have the forest on land, we have agriculture on land, but we also need to look into the sea and use the waste area that we have in the sea and also cultivate the forest of the sea. This is necessary for a sustainable future.
So the other one of the benefit areas we have is environmental sensing, which is about understanding what's happening in the oceans and reaching areas that we haven't been able to reach at all before.
We have this robot. It's an autonomous vehicle that you can send out on missions, and we can program it to go to different depths and different coordinates and so on. And on that robot we have different types of sensors that measures the environment.
Currently in a point where technology is moving forward very fast, and we're having large developments over large areas, global developments. So we need to measure these processes, and we all know what they are. Global warming, fish disappearing, coral disappearing, acidification. And they're not all in the ocean, but the ocean is one of the big elements in these processes that has to be measured, or we're not going to know what's going on. And when things are changing so rapidly, we need measurements. And that's really the impact here, is that autonomy will allow us to measure orders of magnitude more of what's going on.
We use sensors to measure the environment in locations that we can't access in any other way. We have used it to access oceans that are underneath glaciers in Antarctica. And the reason we want to use the autonomous vehicle is that you can't get there with a ship. The ice is hundreds of meters thick, and we simply do it to explore what is there, what kind of processes are going on, and why they are occurring.
So in the marine environment, we are looking for molecules. They are called polyaromatic hydrocarbons. These molecules are very toxic for the environment and can create mutagenic changes in the marine species. And that's why we try to detect them in very low amounts. Everyone tries to reduce pollution. Everyone is talking about climate change. and we know more about the space than we know about our oceans. But if we don't know what it is down there, how can you remediate things then? How can we improve the situation?
The last benefit area is safeguarding society, which is about understanding what's going on and the threats that we potentially may face through the underwater environment.
So we're out here with what we call AUVs, which is autonomous underwater vehicles, so basically robots for the underwater domain. What we're doing out here is we're testing our demonstrator programs, which is these vehicles that are built for being a tool for the researchers.
When we are developing these underwater vehicles, we want to be able to see what they are doing. So what I'm testing right here in Kristineberg is a network of acoustic sensors. In this way we can, in real time, get information from sensors. It can be environmental sensors or a vehicle that is performing a mission.
The biggest strength with AUVs is that they can visit remote areas where humans cannot visit. So what we're trying to do is develop these AUVs to increase the presence in the underwater domain. And that can help us listening for threats, to understand how to better guard our society.
The reason for gathering a lot of data from the ocean is that you want to know what is happening. You want to find objects maybe, and those objects could be related to environmental stuff, it could be related to security defense, finding mines for instance. And then you also want to measure different kind of biological and physiological activities in the oceans. This technology they can really make the society safer by having better control of the underwater domain.
So the near future of SMaRC looks really great. We just got past the halftime evaluation with excellent grades. So we are actually working on now to look at how can we build something more long-lasting as a center, similar as SMaRC.